Hey everyone, welcome to another YouTube video. And in this video, I'll be talking about what a data pipeline is and the components associated with it. Without any further ado, let's jump right in. So this diagram represents the high-level overview about the components or key elements present in a data pipeline. So a data pipeline typically involves collecting data from various sources, and then ingesting the data in a common storage medium, which is also known as data lake in the cloud era right now. And then we have to transform the collected data based on the business requirements or business rules. And then once the data is transformed, you have to serve the data to various teams where reporting, analytics, or ML applications should run on top of the data that has been generated and transformed. In the upcoming slides, we'll go through each and every one of the components over here and then explain in detail what they mean. First one is data sources. So a data source, what does that mean? Data source is just point where you'll be extracting data that will be ingested into your data lake or your storage layer, where transformations will be applied to generate some key insights over it. So there might be many uh, distributed data sources among in your software environment. So there can be, for example, you have to collect data from REST APIs. You have to collect data from IoT services, which uses message queues such as Kinesis, Kafka. And you have to collect data from NoSQL databases like MongoDB, or you have to collect from RDBMS sources like MySQL, etc. So these are the primary examples of what different types of data sources that are available in the market right now. So these data sources or the data that is being generated, you have to have a few key considerations before you design your pipeline. So first one is rate at which data is generated and consumed. If you have an IoT system which is connected to some sensors or some devices, and they follow real-time messaging queues and data is transmitted using distributed messaging systems like Kinesis or Kafka, then you have to have a real-time data pipeline. If you are doing batch mode kind of an operation or IoT data collection, then the rate at which data is generated and consumed, there is a huge gap. Because in real-time data generation, the data is almost available instantaneously. And then when you're doing batch processing, that is, you're transforming the data in scheduled time, then you will be always be lagging when you're applying your analytics. The next one is data quality checks. So when you're collecting data from many different sources, often the case is that during certain times, garbage data or data that is not up to the quality or expectations would be delivered from certain systems at a certain point of time due to human error while uploading or due to some system errors. The files may be corrupted. So as a good data pipeline design, you have to have data quality checks that will check about malinformed data or data that contains duplicates and alert you before the junk data goes through your entire data pipeline and then in turn generates bad analytics or bad insights. So data quality checks are must in any kind of a data pipeline. And finally, dealing with schema changes. So the main problem a data engineer might face is that the ever-changing schema as your data pipeline evolves over time. So typically, when you see any kind of a data pipeline, initially you'll be running your transformation on a few parameters. Then over a course of time, new additional parameters may be added in your source system that will be required for transformation to generate more business insights and to generate further analytics or reporting from additional parameters. So in such a case, if you have fixed schema, then when your source system will add new fields, then you have to change your RDBMS structure as well. And another one is that you have a schema-less design. So a schema-less design doesn't mean that you don't have any schema, but rather you have a schema that evolves continuously along with time. So schemaless designs are very popular right now with the evolution of NoSQL databases. And you can see some popular NoSQL databases being introduced in data pipelines such as MongoDB, Cassandra, DynamoDB, where your data is stored as a JSON object, and over the course of time, as additional variables are being added without any hindrance to the existing data pipeline. Next one is storage layer. So when you're collecting data from various different types of sources, you need a common place to store all this data where your transformation logic will be applied. So before choosing a storage layer, there are some key considerations. You need to have a good knowledge about the storage layer and what are all the limitations the storage layer has. So you need to know about the read write speed, its capacity, and how it can scale over time, and the replication in case if your storage layer fails, and you have a disaster recovery mechanism in place so that you can take a backup in case of failures. And the next one is metadata capturing and data catalog. So like I said in the previous slides during data generations and data sourcing, initially you'll be picking a handful of parameters to apply transformations to generate reports. As time progresses, as your data pipeline matures, you'll be adding more and more parameters for, for generating more and more better insights. In such a case, you need to have a catalog of what are all the data that is being available, and you should capture the metadata as well. So if even if the data is currently not useful for our application, in future that might be useful, and it might be very helpful in upgrading your system as well. Next one is data compliance guidelines. So there are certain guidelines like GDPR where there are certain mandates that on where you should store sensitive data, and the retention time, on how long you can keep sensitive data, what are all the encryption standards, etc. So you can go through about GDPR or HIPAA guidelines online to have an overview about it or to understand more in depth as well. And finally, the data access frequency. So if you guys have worked over cloud services like Microsoft Azure, you might know about hot, lukewarm, and cold data. So storage layers are classified based on the frequency that you are accessing data based on temperatures. So hot data means that you are accessing that data every day or every hour. Basically, that is the data that you are frequently accessing. Next one is lukewarm data, where you'll be accessing the data every week or every month. And cold data, it is basically an archive type of data where you will be storing your data in an archive, and they are only retrieved when in case of a disaster happens, or when you use your main data and you're using this data as a backup for your services. The next component is data ingestion. So data ingestion is basically the process of transporting data from various different sources to a target site or a common location where you'll do further processing, transformation, and then serve the data for analysis. So the types of data ingestion are real-time, batch, push and pull, and lambda data ingestion. So these are the common types of data ingestion. And the first one is real-time data ingestion, which is also known as Kappa architecture overall. The data pipeline is known as Kappa architecture. So in real-time ingestion, we will start consuming the data as soon as the data is available in our source systems. So an example for this type of architecture is typically used in IoT systems, where you will have various sensors that are collecting metrics all the time, 24/7, that is immediately available in your storage layer for transforming the data, and then analytics are served at real time. Next one is batch based or batch process data integration, data ingestion. The next one is batch based data ingestion. So batch based data ingestion, which is typically known as your ETL pipeline, which has been there for ages, where you have a data warehouse where you will be extracting data from various different sources, and then you'll collect it to a common point, and then you'll transform the data and load it into the servers that is used for reporting and dashboard analytics. So batch-based data ingestion is simply scheduling a particular time in a day. Let's say every day at midnight, you will run your data pipeline for 1 hour, collect the data, and then apply transformation, load it into your final analytics dashboard. So in batch-based system, we typically will orchestrate the data ingestion process, or you can say you will schedule it at a particular time, and it will run based on batches. The next one is push-based data ingestion. So in push-based data ingestion, a common example is binary logs and change data capture. So before I talk about binary logs and change data capture, I'll explain what change data capture systems are. So let's say in a database like Postgres or MariaDB or MySQL database, you can implement change data capture. So what that typically means is that whenever you run a transaction which modifies your data, then the modified data logs will be written separately. And then this data is actually like, without directly accessing your database, you can just directly access the logs, and then you could just consume the data that is being changed, thus reducing the load on your database system. So this is known as a push-based data ingestion. In pull-based data ingestion, you can have the same data capture model. Instead of using binary logs to identify the data that has been recently modified, you can use the timestamp field in your change data capture model, and then you can directly access your database, and then from there you can pull the insights based on the recent timestamp changes on which data has been modified recently. And finally, Lambda data ingestion, also known as Lambda architecture data pipeline. So it comprises of both real-time and batch processing architecture. Don't worry too much about Lambda and Kappa architecture right now. I will cover these two architectures about data pipeline in detail in a separate video. Right now, just know what these two types of architectures are in brief. The next slide talks about data transformation. So data transformation is the process of transforming collected data based on the given business rules, which will be useful for downstream use cases. So what this typically means is that the data that you have collected from various different types of sources will be in a common place that is like kept by your data ingestion layer in your storage, and then data transformation scripts. Like for example, if you have a SQL database where you have multiple tables where you will run your SQL queries or SQL files or store procedures, etc., and then transform data based on the given business rules. And this final consolidated data will be served into your reports or analytics dashboards or in your ML algorithms will utilize this data to run predictive models, etc. So before you apply data transformation, the key considerations are the cost and return of investment of the data transformation. Uh, what this means is that like a query, if you are running queries in SQL, sometimes certain queries can be costly and time consuming, and then you need to decide whether is this query uh, which is time consuming for like 30 minutes or so in a real-time system, and is analytics worth it for our business use case. So that is something you should consider while designing your transformation scripts. Next one is limitation of technology with respect to complex business use cases. So as real-time streaming progressed, uh, every team wants data analytics in real time to get the latest insights in their latest insights for their businesses. So in such a case, if you are using data transformation frameworks, distributed transformation frameworks like Hadoop, then you are limited by the technology scope because Hadoop can only do batch processing, and it is very time consuming when you compare it with other distributed frameworks such as Spark, etc. So based on your the speed at which you need to generate insights, you need to pick up the correct distributed framework that can leverage the maximum output for your business use case. And finally, transforming data in batches versus real-time transformation of data in streams. So like I said before, certain business use cases might be time sensitive. So you need to implement real-time data pipelines in certain cases, and certain business use cases need not be like time sensitive, and they can be done in batches in days or weeks. And you need to have an architecture such that you can serve both these types of requirements if the need arises. And finally, your data pipeline requires governance and monitoring. So if you go by definition, data governance is first and foremost a data management function to ensure the quality, integrity, security, and usability of data collected by an organization. So what this means is that data governance, uh, it's a management function that manages and ensures the quality. Like, for example, you need to have data quality checks. You need to have security so that you don't leak sensitive user information to the public or over the network. And you need to have authorization on who can access the data that you are generating. The next point is about monitoring of big data clusters. Yes, as any software system, monitoring uh, and governance is a necessity. Uh, monitoring monitoring gives you an overall picture about the resource consumption of your distributed clusters and the load scheduling among nodes and the scalability of your systems. And it can, and continuous monitoring can help you identify your cluster information in real time, and you can mitigate infrastructure issues even before they affect your pipeline. And finally, data pipelines require orchestration tools such as Apache, Uzi, or Airflow to schedule big data jobs and automate ETL jobs as well. So you might wonder that a simple cron job in your Linux server uh, can be applied to the situation. Well, the answer is yes, you can apply a cron job in such situations. But when your cron job fails, it becomes very hard to debug issues in your data pipeline. So that is why you require orchestration tools like this, which offer sophisticated dashboards and debugging tools to pinpoint and mitigate issues. So this is an overall view about what a data pipeline is and what are the key considerations that you might need to have in order to build a data pipeline. And I'll be uploading more videos about what ETL pipelines are and what are ELT pipelines and about the various tools of orchestration, about the various architectures like Lambda, Kappa architecture, etc., and the various data terminologies such as data warehouse, data marks, and data lakes. So if you're interested in this type of content, then do subscribe. And I'll be uploading videos regularly. So thank you and stay tuned.